That's right, Tom Crazy Cat ain't the only one that can do stuff now. Look, I can make lines. I can do stuff over here and then delete it. Go away. Go away, Tom. Go away, Tom. Crazy cat. Meow. Okay, so in here, obviously just playing around with some things. So let's just undo all that. And I was clipping on YouTube, just using screen capture here, and I'm taking out the whole setting. I could actually go screen capture and just get the whole screen maybe, so that way I have it in there. But I think I'll always get this still, which is all right. I don't need that much differential on a full screen YouTube. You know what I mean? I just want this. This is important. So what else you got, Sharp? Too bad I can't click next on here. Oh wait, I should be able to. You close, you go away. There we go. Alright, so what else we got? We got some math. Alright, good. Good. I'm glad what you brought to me this morning. This is very appreciative of you. We got some orbitals and black holes. It's a derivative, so think about it like programming. Like derivating x. I want an x to do something. I want this box to be in a certain quadrant of the screen, and you'll have this momentum. And what do I mean by this momentum? Well, I mean like this momentum. It'll want to do this. I wanted you to go over there, but it's got that spin. It's got this angle x and y to the code. Well, here we go. If player x, if there's all right. So derivative x or derivative t if and when you get derivative velocity. Well, how fast are these things going? We got to check the speeds on here, and that'll be correlated to each independent one or time being x. We know the counter on the clock to all the ones and zeros, blah, 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 reset, goes to that increment of time, and I need to set velocity on those clock intervals. That's going to be equal to A1, G equals gravity, M2. That's the second move. You can get into Fibonacci with F2 equals F1 equals 1. Basically, in this quadrant, you have, in this corner, you have F1. In this one, you have F2, and basically this is that F3 or 1. This is 1. We do all ones off of a grid like this. Every one of them. So we're saying that these are in brackets, but are they in brackets? Some people just got to have it right next to each other before they really see it. And this is the virtual way to process the math. Out here in physics, it's a little different. Derivative is, we're saying, well, I think x is the ball. X1 is, we're going to use the same math on this, even though they're different sizes. That gives them different derivatives. That gives them different clocks, Andromeda paradox stuff. And if their velocity changes, that puts a spin on the problem to determine the mass of this thing and be a problem. So just moving along. Just moving along, Sharps. Okay, and then you throw the ball. It comes over. And given the velocity in which you throw that thing, or the mass of that object, let's say it's iron, let's say it's cotton, let's say it's, whatever inside here, you'll get Randy Marsh talking about the TMI. Average, small, nice. Alright, so we'll get in here to be writing some stuff up on the board. As you do. Where'd you go? Length over, what is it, girth or something? Width over girth, length over derivative or alpha. Yeah, you'd be amazed because that's what this. You see this little line right here? Let's go back. Well, it could be this line, but that's alright. This line right here. Where's my little drawing thing? It is this line right here. This murder line right here. This one too. Okay. Undo. Okay. So I'm having some fun. There's lots of ways you can set up PowerPoint presentations. Now, this isn't a live class, but this is all set up. Remember, I could just bring this in here. Maybe I hook something up into the corner of the screen down here. Maybe we do those things. And this goes on a projector somewhere within a couple of clicks. Excuse me. But in here, like I said, this is, alright, you want to go to a YouTube video. You want to get those clip arts out here, you figure out your scale, and you get them clipped art. It's a math. This is fair usage. Well, maybe not this. But in sense what they're doing with this math problem. I'm not using this episode I'm using this episode to actually give me some science. This is a very now well this well all right. So anyways, you get in here and this is a pretty complicated math problem. What is the average? What are you going to get out there and inch and stick that thing? Well, that's an x derivative over derivative t. Oh, you're going to have an average to u too on that TMI. So that's again one of those notes that again you can use this material in such a way. What are we doing here? Yeah, we can use this material differently to augment situations. We can say let's augment reality a little bit. We'll put a little Scranton reality anchor over here in the corner about some of this information. Then let some of this play off and see how we can click the buttons together, or if it even does without being a problem. I mean, how do we want to be able to set this up for programming? Because this is programming. All the lights and blinkies are the same. Which ones you click in an order become a program. So I wanted to give you that note. I'll catch you on the next one.